Welcome, everyone, to Session 16 of Dynamic Topology. You know, we've really reached a major milestone here. Think of today less like just another session and more like a capstone, a moment to celebrate all the incredible foundational work we've done together this entire first semester.
Right from the very beginning, our entire approach has been driven by this one powerful idea from the books forward. This course, it's not a spectator sport, right? We're here to actively build mathematics, to get our hands dirty, and to really truly understand it from the inside out. And this session, well, it's the ultimate expression of that whole philosophy.
So, to really appreciate just how far we've come, let's do a quick lightning-fast review of the mathematical universe we've built. I mean, we literally started from nothing, from first principles, and built our way up piece by piece. It all kicked off with the simplest, most basic idea you can imagine, the set. Just a collection of stuff. This was our primordial dust, the very first building block that everything else was going to be made from.
But, a pile of dust isn't all that interesting on its own, so we gave our sets structure. By defining a topology, we turned them into topological spaces, and that's where the real magic started. We created a landscape where we could finally start exploring some really profound ideas. One of the first huge properties we dug into was compactness. It's a way of making a pretty intuitive idea rigorous, something you can kind of think of as topological boundedness or being self-contained. And it turns out this property has some incredibly powerful consequences down the line. And then we defined connectedness, which is really just the formal mathematical way of saying a space is all in one piece. It sounds simple, I know, but this idea is what let us tell the difference between a single continuous line and two separate lines, a distinction that's absolutely fundamental for everything that comes next. And here's where you see how we started combining these ideas. We took compactness, we grabbed connectedness, we added the structure of a metric space, and we forged one of the most important objects in our entire study, the continuum. It's this rich, beautiful structure that just shows up everywhere in topology. So you can see the logical chain, right? Each step was built firmly on the one that came before it. We went from just simple collections to structured spaces to find their core properties, and then use those properties to build and analyze these complex, fascinating mathematical objects. It's just a beautiful logical climb. Okay, so let's shift gears and talk about how we made that journey. Because it wasn't by just passively watching me talk, was it? We learned using Gordon Wyburn's unique and, demanding style, a method that is all about active creation. This quote just captures the spirit of it perfectly. The expectation in this course isn't just to understand the theorems, it's to prove them, to build the logic yourself. Your task, our task, has been to be the mathematician in the room. These were the ground rules, and they might seem strict, but they are all designed for one single purpose: to build genuine, deep understanding and an unshakable confidence. See, the goal isn't to find the answer in a book, it's to find it inside your own reasoning. That is how you truly learn to create mathematics. Which of course brings us to a really crucial question. After all this work, after struggling through those definitions and exercises, how do you really know you've mastered this material? How do you prove it to yourself? The answer lies right here. The first semester examination in the book, well, it's not a test in the way you might think. It's a challenge. It's the living embodiment of the Wyburn method, a collection of theorems just waiting for you and you alone to prove them. So, this is your next assignment, your capstone project for the whole semester. The challenge is to open the book to the first semester examination and just engage with it directly. This is your moment to apply everything we've learned and to build those proofs from the ground up with your own two hands. And please, don't think of this as just an exercise. As John Kelly so beautifully puts it, this is a creative act. By reconstructing these proofs, you are walking in the very footsteps of the mathematicians who first discovered them. It's that final step in building the confidence you need to, one day, create original mathematics all on your own. But hey, once you've met that challenge, this journey is far from over. In fact, everything we've done this semester has been preparation. It's all been about laying the groundwork for what's coming next in semester 2. If the first semester was all about forging the tools, defining sets, spaces, compactness, connectedness,
Then the second semester is all about using those tools to explore whole new dimensions of topology. We've built the factory, now we finally get to see what it can produce. And just look at what's waiting for us in part B of the book. We're going to explore how to multiply spaces together to create product spaces. We'll learn how to break down complex spaces into simpler parts. We'll study the beautiful ideas of homotopy, which is the mathematics of continuous squishing and stretching. These are powerful, amazing topics, and we now have the foundation to really tackle them. You have done the hard work. You've laid a solid foundation, stone by logical stone. And I am just incredibly excited to see the amazing, elegant structures we're going to build on top of it together in the sessions to come. So I'll leave you with this thought. The foundations are secure. The tools are in your hands. The only question left is, what new structures, what new insights are we going to build together? I can't wait to find out. I'll see you in semester 2.